So where we are? So up till now we have discussed that when anthracene will be oxidized at higher temperature, approximately at 250 degrees centigrade. So there is formation of two molecules of benzoic acid. So from here we have confirmed that anthracene will be having two molecules of benzene ring. But this is not true. Again the study is going on, or further study is going on, which will produce two molecules of benzoic acid after the oxidation at high temperature. Now, but the problem is the skeleton contains 14 carbon atoms and which will be feed into the 10 hydrogen atoms and retain the quadrivalency, that is carbon valency 4, which will be retained in this structure of the carbon atom, which will having the middle ring must be closed. So depending upon all the study, whatever we have studied up till now, first the reaction with halide, they are going to produce bromoanthracene. Second, when they are reacting with potassium hydroxide, they are producing hydroxyanthracene. See both of these structure, both of these having 14 carbon atoms. Now, whenever we are oxidizing this anthracene at high temperature with oxygen, they are going to produce two molecules of benzoic acid. Now, by clubbing these two important data, finally we have concluded that anthracene is having 14 number of carbon atoms and they are going to fit with the 10 hydrogen atom. Throughout this ring, the carbon valency 4 is maintained. That means we come to the conclusion that the middle ring in the anthracene, see this is the structure of anthracene. This is a structure of anthracene from everything data which we have covered up till now. That means the middle ring which is there in the structure of anthracene is closed in between the structures of the two benzene rings. So that means the middle ring is closed and the structure of anthracene which is consistent with the foregoing reactions of three benzene rings which are linearly fused. So structure of anthracene will contain linearly. So depending upon all these data, we have concluded that anthracene will contain a structure of three benzene rings, that is from halogenation, from oxidation, from hydroxylation. We have concluded up to that anthracene will contain 14 carbon atoms, 10 hydrogen atoms, and the middle ring is fused. But this fusing of three benzene rings, in which manner? In the linearly manner. Now, keep in mind or by heart this word, anthracene contains linear fusion of three benzene rings. So this structure has been confirmed by the many. How we are going to confirm the structure of benzene ring? By so many synthetic procedures. So this is the structure of anthracene and which will be confirmed by many synthetic mechanisms or many synthetic procedures. So for that, the first synthetic method for the confirmation of structure of anthracene is by Friedel-Crafts reaction. So this is an synthetic method as well as structure confirmation method. First method is by Friedel-Crafts reaction. In this by Friedel-Crafts reaction, we are going to use acyl chloride as a starting material, that means benzoyl chloride. So this benzyl chloride, when it reacts with, so this benzoyl chloride when it reacts with methyl chlorobenzene, so that is formation of, so whenever we are going to react the two benzyl chlorides, condensation reaction, two benzyl chlorides will condense in the presence of aluminium chloride. So this is an condensation reaction. So there is formation of an intermediate product. What is that intermediate product? 9,10 dihydroanthracene. See, these two benzyl chloride rings has fused together by using an molecule, that is aluminium chloride. So these two benzyl rings fuse together at 9,10 position. So what is the name of the intermediate product? 9,10 dihydroanthracene, which is first form, which then laterally eliminates these two hydrogen atoms. So that is for me removal of these two hydrogen atoms and fused third middle benzene ring is obtained. So there is formation of an anthracene. So this is the first method for the synthesis of anthracene by benzyl chloride condensation. So anthracene is also formed by the Friedel-Crafts condensation between the benzene and methylene bromide. So same mechanism, but starting materials are different. That is by using a benzene and methylene bromide, or between the benzene and acetylene tetrabromide. So Friedel-Crafts benzyl chloride reaction involves condensation with the benzyl chloride, condensation of benzene with methylene bromide, or condensation between benzene and acetylene tetrabromide. All will condense by same mechanism via formation of 9,10 dihydroanthracene at an intermediate product followed by the formation of anthracene. So this is the first method of formation of an anthracene. Second method, by heating orthobromobenzyl bromide with sodium. So this is the second method for the synthesis as well as structure confirmation of anthracene. How? By using orthobromobenzyl bromide with sodium. So when we react these with sodium, two molecules of orthobromobenzyl bromide we are using as like that of our first method, and they will condense in the presence of sodium. So simply condensation reaction. Again here also there is formation of 9,10 dihydroanthracene, which upon oxidation there is formation of anthracene. So this oxidation will be results into formation of dehydrogenation, removal of hydrogen, that is formation of water molecule, and the resulting product is anthracene. So this is the second method for the synthesis of anthracene. Now, the same method also used for the formation of phenanthrene. I again memorize the word linear. The phenanthrene is also a triple fused compound of benzene ring, but this phenanthrene is not fusing those benzene ring with linearly manner. It is in the angle position. See, the structure of phenanthrene and anthracene are quite similar. Both of them will contain the three benzene rings, but in case of phenanthrene, the fusing of benzene rings will be at an angle. And here, the fusing of benzene ring in the linear position. Now, come to the point. The same method by using an bromobenzyl derivatives, we are going to synthesize phenanthrene by using a sodium atom. This fusing will be at an angle because the position of bromine and methyl functional group at an angle. So the same method we are going to use for the synthesis of phenanthrene. So everybody understood the difference between phenanthrene and anthracene. Here there is anthracene and phenanthrene. Here there is linear fusion of benzene rings, and here there is at an angle there is fusing between the benzene. Now, third method for the synthesis of anthracene. So, what will be the third method? When phthalic anhydride in benzene solution is treated with aluminium chloride. So this is an phthalic anhydride. When this phthalic anhydride will condense with benzene ring in the presence of aluminium chloride, so there is formation of intermediate product. This intermediate product, when will heat with the concentrated sulfuric acid at 100 degrees centigrade, there is formation of an anthracene. So this is an anthracene, and this anthracene, upon reduction in the presence of zinc dust, there is formation of an anthracene. So when this phthalic anhydride will react with benzene in the presence of aluminium chloride, there is formation of orthobenzoyl benzoic acid is formed. This orthobenzoyl benzoic acid, when reacts with the sulfuric acid under heat condition, there is formation of an anthracene, and this anthracene, upon reduction in the presence of zinc, there is formation of an anthracene. Now, according to who, this method is given by the who in 1953. Instead of aluminum chloride, we can also use polyphosphoric acid as an cyclizing agent. Now, second method, alternatively, orthoquinone may be prepared by the action of aluminum chloride with thalloyl chloride. So, phthalic acid, thalloyl chloride, phthalic acid, upon chlorination will form thalloyl chloride, and this thalloyl chloride, when reacts with benzene in the presence of aluminum chloride, similar method. Here we have used anhydride. Here we can use thalloyl chloride. When fused with aluminum chloride and benzene ring, again there will be formation of an anthracene, and this anthracene will be reduced in the presence of zinc dust, so we can re-obtain the anthracene. So this is the third method for the formation of or the synthesis of anthracene. Now, next method for the synthesis of anthracene will be prepared by means of ELB process. Now, what is this ELB process? When there is reaction between the ketone derivative. Now, this is an ketone, that is methyl diaryl ketone. Okay, so or we can say methyl dibenzene ketone when undergo condensation. So we are heating this mixture or refluxing this mixture at about what temperature? Approximately at 400 and 450 degrees centigrade. So this two rings or this diaryl ring will be fused at high temperature. This fusing and cyclizing process at this higher temperature is known as ELB process, which is only by means of preparing certain polynuclear hydrocarbons. This procedure we are going to use for certain polynuclear hydrocarbons. So simply condensation reaction at high temperature, we are going to fuse this diaryl ketone by removing a water molecule. So we can synthesize anthracene. Now, next method for the synthesis of anthracene may be synthesized in the following way by using a naphthalene as an starting material. Now, what is naphthalene? Already we have discussed. This is an in part 1. This is an two fused benzene rings are there. Now, these two fused benzene rings also can be used to synthesize three fused benzene rings, that is naphthalene. Now, this method will show us that is by using naphthalene for the synthesis of anthracene. This can be confirmed that anthracene contains a structure of naphthalene. So, how we are going to use naphthalene? When 1,4-naphthoquinone, oxidation product of naphthalene, that is 1,4-naphthoquinone, can be used in the synthesis of anthracene. How? When 1,4-naphthalene condenses with dialder condensation reaction with butadiene. When we are going to condense 1,4-butadiene with naphthalene, 1,4-naphthalene, so this condensation will result into formation of 1,4-dihydroanthracene. Naphthalene when fused with or when condenses with 1,4-diene, there is formation of an 1,4-dihydroanthracene, and this 1,4-dihydroanthracene followed by oxidation will result into anthracene. Again, the same reaction. This anthracene in the presence of zinc dust will be reduced and there is formation of an anthracene. So this method is particularly when we are going to use naphthalene for the synthesis of anthracene. Second method, again when we are going to use naphthalene for the synthesis of anthracene. When naphthalene will react with sulfuric acid followed by ethanol, so there is formation of an ester derivative, that is 1,4-dihydronaphthalene 2-carboxylic acid ester. Now, this is an tedious process, nobody will ask in the exam, but you should know that is naphthalene, there is formation of an ester, naphthalene ester, and this ester followed by ketonic hydrolysis, there is formation of an with the help of zinc distillation. There we can obtain the anthracene. So these many methods are there for the synthesis of anthracene. First, that is from benzoyl chloride. So many methods we have used from naphthalene, from ketonic derivatives by Friedel-Crafts reaction. We are going to, so 5 methods are there for the synthesis of anthracene. Now, as like that of naphthalene, here also we are going to confirm the position of double bond in the anthracene. So, to determine the position of double bond in the anthracene, many structures proposed for the anthracene. Now, in case of structure 1, this is more acceptable structure of anthracene because as like that of naphthalene, the middle benzene ring is having, or the lateral 2 benzene rings of this anthracene is having 2 benzene rings. While determining the structure of naphthalene, we have discussed that the 2 benzene rings, but here in this case, the fused middle benzene ring will form the 2 benzene rings, stable benzene rings. So this one is the more acceptable structure of anthracene. So structure 1 was accepted by many because of the synthesis of anthracene from benzene and acetylene tetrachloride. We have discussed in case of method number 1. This structure, however, has been considered unlikely for various reasons. So what are the reasons why we have conferred or why we have structure is confirmed this one? Number 1 reason, the synthesis of anthracene from naphthalene and other synthetic methods indicates absence of double bond at this position. 5 methods we have used for the synthesis of naphthalene, anthracene up till now. All those methods confirms that there is absence of double bond at this position. That means this structure is confirmed. Second method or second reason for the confirmation of the structure of anthracene is anthracene adds on malonic anhydride to form endo-anthracene malic anhydride. This addition occurs in the middle. See, the lateral 2 benzene rings are already stabilized by the position of the presence of double bond, and the addition of this malic anhydride will be taken place across this 2 carbon atoms. 9-10 position. That means due to this addition of malic anhydride in the middle ring will confirm that a structure of anthracene has lateral two positions of the or lateral to benzene, terminal benzene. Since the middle ring behaves as a die for the addition of malonic ester, this indicates that it contains conjugated double bond. So these two reasons are there. That's why we have confirmed the structure. One is the stable structure. Third reason, by X-ray analysis, shown that all the carbon atoms of the anthracene lie in a plane, and the distance between the para-carbon atom of each ring is the same as like that of benzene. So that means anthracene has three benzene rings fused together. So all these evidence suggest that point towards the anthracene being a resonance hybrid of structures. So structure 2 and 4 are the resonating structure having double bonds at para position. That is, these are the resonating structures of anthracene, and the resonance energy for anthracene is at 105 degree calorie per mole. Now, anthracene is going to have alternate hydrocarbon, and the pi electron densities are at all positions. Today we will